Day 333 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2401, longest night subarray. The difficulty level is medium, but don't worry, we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go in and check out that link in the description so you can get your some. Now let's see what the question says. You are given an array nums consisting of positive integers. We call a subarray of nums nice if the bitwise AND of every pair of elements that are in different positions in the subarray is equal to 0. Return the length of the longest nice subarray. A subarray is a contiguous part of an array. Note that the subarray of length 1 are always considered nice. All right, y'all, that sounds simple enough, or does it? It doesn't really sound that simple. So let's go ahead and take a look at these examples just to make sure we are doing this problem correctly. So in example 1, we have the input nums equals an array of integers 1, 3, 8, 48, and 10. The output is 3. Explanation says the longest nice subarray is 3, 8, and 48. This subarray satisfies the conditions 3 and 8 equals 0, 3 and 48 equals 0, and 8 and 48 equals 0. It can be proven that no longer nice subarray can be obtained, so we return 3. Okay, so let's go through this just to make sure that we really understand what's going on here, right? Just in case it's not making sense to everybody. So first thing I'm going to do is I'm going to convert every integer in this array into bits so that we could better understand what's going on into binary. So in order to do that, let's start with 1. We'll say, so that's 1 in binary. Boom. Then we have 3. Let's do 3. So that's 3 in binary. Then we have 8. So 8 would be, that's 8. Then we have 48. So 48 would be, clean this up for y'all. And then we have 10. And 10 would be, oh, sorry, this is 48. 48 has another 1 right there. I mean, another 0 right there. Then 10 would be, okay, so that's 10. So first thing we need to understand is what the bitwise AND operator does. So the bitwise AND operator compares each bit of two numbers and returns 1 if both bits are 1. Otherwise, it returns 0. So let's just compare these two numbers at first, just so we can see an example of where it will return 1. And as you can see, so if we compare these two numbers, it'd be 0, 0, that'd be a 0, 0, 0, that'd be a 0, 0 and 1, that's still a 0 because it's not a 1 and 1, but this is a 1 and 1 right here. And with the AND operator, when we come across a 1 and a 1, it returns 1, and that's not 0, so that's not what we want. So we know 1 and 3 doesn't work, and it's not 1 cannot be a part of the nice subarray. Now let's do 3 and 8, right? So like they start over here. First they do 3 and 8. So now let's compare 3 and 8 and see if that equals 0. So let me copy and paste that. Clean that up for y'all. Then we come right here. So 0 and 1, that's not 1 and 1, so that's a 0. 0 and 0, that's not 1 and 1, so that's a 0. 1 and 0 is not a 0, so that's a 0. And same thing, 1 and 0, that's not a 0. So boom. So we know 3 and 8 is going to equal 0 like it says right here. Boom. Now let's do 3 and 48. So we had the 3. Then we had the 48. Boom. Sorry, y'all. So hold on. Let's clean this up a little bit. Should be 2 more. We could just add 2 zeros to all of these, just so it lines up with the 48, and we could see better what's going on. So boom, put a 0 right here, 2 zeros right here. I'm sorry. Boom. So now, okay, now let's do 3 and 48. So let's do the 3. Then we could do 48. Boom. Okay, so now when we compare 3 and 48, we know it's going to equal 0, but let's just go through it anyway. So 0 and 1, 0, 0 and 1, that's going to give us a 0. 0 and 1, that's going to give us a 0. 0, 0 going to give us a 0. 0, 0 will give us a 0. 1 and 0 will give us a 0. And 1 and 0 will give us a 0. Boom. So like I said, 3 and 48 will give us 0. Boom. Now we need to do 8 and 48. So let's change this to the 8. Bada boom, bada bang. Okay, so now let's compare 8 and 48. 0 and 1, it's going to give us a 0. 0 and 1, it's going to give us a 0. 1 and 0, 0, 0, 0, 0. So it would be 0, 0, 0. Boom. And once again, you can see 8 and 48 give us a 0. Now let's say we try to do a 10, because as you can see, if we did 10, say we put a 10 right here. Boom, put the 10 right here. The 10 and 48, as you can see, would give us 0 as well. It'd be 0, 0, 1 is 0, that's 0, 0, 0, 0, 1 is 0, 0, 0, 0, 0. But it's not, it works with the 48, but it does not work with the 8 or the 3. So let's see if we put the 8 right here. 10 is not going to work with the 8, because as you can see right here, it would go 0, 0, that'd be 0, 0, 0. But one right here, we have 1 and 1. So we put a 1, then 0, 0, 0, 0. I mean 1, 0, then 0, 0. But as you can see, it's not 0 because we have these 1s right here. So 10 and 8 doesn't work. And also 10 and 3 doesn't work either, right? Boom. So we tried 10 and 3. That wouldn't work either. So it'd be, oh, we can start from over here. Sorry, y'all. Go 0, 0 be 0, 0, 0, that's 0. 1 and 0 is 0, 0, 0, 0. But boom, we get right here, it's a 1 and 1. So that'd be a 1, and 0 and 1 would be a 0. So once again, that does not work either. So boom, we got to get rid of it because it doesn't work. So we can't use the 10, because as you can see, with these 3 elements, they all work with each other. 3 works with 8 and 3 works with 48. 8, that means, and 8 works with 48 as well. So that means 3 works with 8, that equals 0. 3 works with 48, that equals 0. And then that also means if we did 8 and 3, that'd be 0. And we did 48 and 3, that'd be 0. And then last but not least, we do 8 and 48, that's 0. So as you can see, all of these combinations, no matter how we work them, they'll still equal 0, which is why we cannot include the 1 or the 10, because the 10 might work with 48, but it doesn't work with 3 and 8. You know what I'm saying? And we need it to work. We need all of the 3 numbers, or all of the subarray to work to for it to equal 0, for it to count. So that's why this longest subarray is 3, because there are 3 elements in the subarray. Boom. Principle same. Let's go ahead and look at example 2. It's the same principle, but in this case, where it's a case where note the subarrays of length 1 are always considered nice. And in this case, so let's go through it. The input nums equals an array of integers 3, 1, 5, 11, and 13. The output is 1. The explanation says the length of the longest nice subarray is 1. Any subarray of length 1 can be chosen. So that just means none of these 2 numbers will work together to equal 0, but 1 by itself, or 1 element by itself, counts, right, as a subarray, because it says right here, subarrays of length 1 are always considered nice. So now that we understand the question, y'all, let's get into the fun part, actual solution. Solution is way more easy to understand than the actual question. So let's get into it. Now, the first thing we need to do is we need to create a variable to store the maximum length of the nice subarray. So in order to do that, we could just say var, we could call it max length, set that equal to 1. Then now we need a left pointer for the sliding window, so we can declare another variable. We could just call it left and set that equal to 0. Then we need a bitwise representation of the numbers currently in the window, so we could declare a variable. We could just call it use bits, and we could set that equal to 0 as well. Now we need to iterate through the array using the right pointer. So we can say for right in 0 dot dot less than nums dot count. So 0 up to nums dot count, that's what that means. Boom. Now if adding nums right causes a bitwise conflict, we need to shrink the window from the left. So we can say while, then open up the parentheses, use bits and nums square bracket right, come outside the parentheses, exclamation point equals, so does not equal 0. We're going to open up the brackets. And we need to remove the leftmost element from the bit mask using the bitwise XOR operator. So in order to do that, we can say use bits, then we use this up caret like that and say equals nums square bracket left. And now we need to move the left pointer to shrink the window, so we could say left plus equals 1, just like that. Now we need to add nums right to the current set using the bitwise OR operator. So to do that, we can come right here outside of the while loop, and we can say use bits, exclamation point equal sign, so does not equal nums square bracket right. Come underneath that, and we need to update the maximum length of a nice subarray that we found so far. So we could say max length equals max, open up the parentheses, max length, comma, right minus left plus 1. Just like that. And now we need to return the maximum length of the nice subarray. So we could come right here outside of the for loop, and we could say return max length, just like that. So let's go ahead and give this a run, y'all. Make sure it runs like it's supposed to before we submit it. Okay, we got the wrong answer, y'all. So let's see where we went wrong to get this wrong answer. Sorry, y'all. Give me a moment while I figure this out. Thing about getting the wrong answer. Oh, it shouldn't be an exclamation point. This should be just a vertical line. So now let's go ahead and give it a run. 9 times out of 10, when you get the wrong answer, the math is wrong somewhere. And that's what it was. That should be a vertical line. Should not be exclamation point. Because we're trying to use the bitwise OR operator. So now that it's accepted, let's go ahead and submit it. Make sure it's still accepted. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift. That's what I'm talking about. That's what I'm like to see. Those are some good numbers right there. So let's keep it up. And with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.